So if you see, we can use, in this example, we'll see how we can use the recursive function to display the Fibonacci numbers, like the Fibonacci series. I think you all know what you mean by a Fibonacci series. We have generated this Fibonacci series using our iterative statements while, do while, and for. So this is our Fibonacci series. How we are getting our Fibonacci series? The first two things are constant, 0 and 1 is same. But from the third element onwards, it will be the sum of previous two numbers. So 0 plus 1 is 1, that's why it is 1 here. And then 1 plus 1 is 2, that's why this is 2. 1 plus 2 is 3, this is 3. So like that, we will be generating the Fibonacci series. Now to generate this Fibonacci series, we can do this one simply by using this iterative statements also. But if you are asked to generate using functions concept, then you can use this recursive function concept also. Now here, we need to highlight three things. What are three things? We need to use the decomposition, we need to use the composition, and we need to find out our stopping condition. Now, in our case of generating the Fibonacci series, our stopping condition is the first value and the second value. That means Fibonacci of 1 is 0. That means the first value is 0. And Fibonacci of second value is 1. That is our stopping condition. And what is our decomposition? We are going to try composition is we are performing the addition, because if you see here, if you want to find the Fibonacci of this number, how you are getting the Fibonacci of this number, 1, 2, 3, 4. How you will get the fourth position Fibonacci number? You will get the fourth position Fibonacci number by taking the addition of previous two values. So that is our composition here. And how you will get this position value? This position value is nothing but, again we need to get the Fibonacci number of this one, and again we need to get the Fibonacci number of this one. So this is our first position, this is our second position, right? So this can be generalized like this. So nth position Fibonacci number, if you want to get, then we need to add the n-1 Fibonacci number and n-2 Fibonacci number. Earlier two. If it is 4, you need to take the third value, and you need to take the second value, and you need to sum up that one. Isn't it or not? So this is our composition, and this is our these two are decomposition. This is our composition, and this is our base cases. Now let us write the logic for this one, and I'll show you how it will be executed. Is these three things clear to you all? How we have done the composition and decomposition? You will be getting a particular position Fibonacci number by adding the earlier two positions Fibonacci numbers. So if you want to get the Fibonacci number of fourth position, you need to take the third position and the second position, and you need to add that one, right? So this is how Fibonacci series will be generated, and these two are base cases. I'll show you how recursively we are doing this one. Fibonacci n-2 is not a composition, it is a decomposition. Our composition is of addition, plus operation is our composition. Okay, plus operation is the composition, decomposition is these two parts. Now let me show you the logic behind this one. What we have done, we have a main method also. I'm not talking about the main method, and from the main method I'm calling this Fibonacci, and I am what I'm doing, I am passing a parameter up to which number I want to generate the Fibonacci series. Here I am trying to find out the Fibonacci series. Okay, now nth Fibonacci, I am taking one variable. N value should be always greater than 1. Why it should be greater than 1? Because the first two values we have fixed, we want to try it from the third position onwards only. Okay, so how many numbers you want to generate? You are talking about that one. Okay, so if the position value is greater than 2, then we are getting the Fibonacci number by adding the earlier two Fibonacci numbers, and we are repeatedly calling the Fibonacci of n-1. That means, let us consider 4 you have given. So 4, that means 4 minus 1 is 3. 4 minus 1 is 2. It will repeatedly calling the same function. Let me show you that one. Let us take 4 is our Fibonacci number. We want to generate up to 4 numbers, the Fibonacci series. So how it will be decomposed? Fibonacci 3 and Fibonacci 2, isn't it or not? In our example, if you see 4 is greater than 2, it will be decomposed into Fibonacci of n minus 1 and Fibonacci of n minus 2. So let us highlight the decomposition parts. Fibonacci of 3 and Fibonacci of 2. Again, Fibonacci of 2 or Fibonacci of 3, how it will be decomposed? Fibonacci of 2 and Fibonacci of 1. Okay, we have our base conditions where 1 and 2 we have fixed. What is Fibonacci of 1? It is 0 and Fibonacci of 2 is 1. Right? So as we have reached our base condition, we need to go back and we need to start with our composition. What is our composition? We are performing the addition operation between these two. So 1 plus 0 is, we are performing the addition which is 1. Right? So here we will be getting 1. Now this 1 and Fibonacci of 2, we know the base condition which is 1. And 1 and 1 again we are going back and we will be getting the Fibonacci of 2. Right? So at the 4th position, we will be having the Fibonacci number of 2. Are you understanding? Are you understanding? So this is how we are displaying the Fibonacci number at a particular position. Got it? So a key, then this is the second example. So whenever you want to do any recursive function in your program, then you need to remember 3 things is, always you need to use some branching statements like if else we have used in our program, if else you can use, and one that you can use, or else any other branching statements can be used. And one more thing you need to make note is, always try to divide into smaller versions, like what we have done, n we have divided in n factorial, we have divided into n minus 1 factorial, right? So like that you need to divide your larger problems into smaller compositions, and then we need to have a stopping condition always to terminate your problem. If you don't have a stopping case, then it will be creating a problem where the function will be repeatedly calling itself. Got it? So these 3 things you need to make a note, all of you. Right? So the normal template for having your recursive function is, you can use if else or any branching statements. There you make a note like whether there is a decomposition added in your problem or not, whether there is a composition added in your problem or not. If you have any base, you have added a base case or not. These 3 things you make a note. So this is a normal template we will be following. Okay, this is the shortcut I'm telling you. Why? Because whenever you want to add any recursion in your code, then make a note of these 3 things. Check for a base condition first, check for a decomposition, check for the composition. Whether you are doing all these 3 things correctly or not, and then you check you have added a branching statement or not, if else. Okay, and if you are not returning anything, you simply put void here. If you are adding the return statement, whatever value you are returning, that data type you need to add here. As simple as that. So this is a template you can follow whenever you are using. Okay, so this is one more template. If here I have added the else. If you don't want to add the else part, simply write down the initial value as the base case. What we have done, like fact value you have given 1 while learning the factorial, right? So you can use this template by adding if else, and in the else part you will be adding the base case, or else you can simply omit the else part and initialize with some value to have the base case. So these 2 templates can be followed to have your recursive functions. Got it, all of you? So you can see here. Now what I want to do is practice this code and the next code, and you people check what happens in this case. Okay, do check these 2 codes and let me know what you are getting in these 2 cases. Okay, now before going to learn in detail, what we'll do is let us learn let us write down the code in the compiler and let us check how it will be executed. I hope you all are clear. I hope you all are clear with this 2 concepts, with this finding the Fibonacci number, right?